right, we have started the stream. I think. Hopefully. Maybe. Got that. We want this thing. That's because I don't have a challenge started yet. Start a random challenge. Make sure that things are working. Let's see here. Twitch. What the heck is this? Oh, there we go. That looks like we are live. Oh, there we go. Cool. All right, we are live. We are likely on our last office hours. Maybe we can do a bonus one. We'll see. If people have a very high level of interest in it, I can't really commit to that, but you know, there's a chance. 365. Oh boy, we got some immediate interest in some bonus office hours. 365 is in finals week. We're all in finals week at ASU. I believe our last module though is in fact due today, right? Yeah, 13 hours. Yeah. So we still have our last assignment due today. And then I believe, let's see here, we'll not make anything up. Let's pull up the syllabus. I believe people have until like Sunday night or something like that. Of course. I believe people have until Sunday night to get half credit on late things. So that's why I would consider doing a bonus office hours to facilitate that. I don't really, I think I've got a lot going on this week, but I can, there's a lot of interest in it. I can see what I can do now that I've already said that. Let's see here. Yeah, so the 5th is Sunday, and this says late submission until May 5th, 11:59. Yeah, so the very last moment of Sunday is when everything is due, Arizona time. Okay. I thought for non-course. You know, I was okay. This we are discussing what's going on in my head, which I don't want to commit to, but I was thinking about holding a bonus stream. So I've been a little bit slacking on the memes this semester in terms of reviewing them, because full disclosure, most of your memes were really bad. So I wasn't very motivated to look at your memes. It was very disheartening seeing your bad memes. So I kind of just stopped looking. There is a chance that I might do like a 30-minute power meme review or something, where I go through every single meme from this semester. And like, I think ChatGPT might be able to generate a web app very quickly that gives me like Tinder meme review, right? Like where I can just swipe left, swipe right, and then boom, everyone I swipe right gets extra credit. If ChatGPT can generate this app very quickly, and then I can be like 2 seconds a meme, we might do that. You know, I'm very non-committal here on what I'm saying about happening this week, but maybe I will look into doing that. And then future students can look back on this meme review to understand what the heck a bad meme is and what the heck a good meme is. Hopefully there's at least a few good memes in there that I just missed because the memes are boring. All right, so maybe we'll do that. Is there a possibility of having an in-person office hours? Probably not. At this point in this semester, we're in the last week. I don't think that's going to be very feasible at this point. Yeah, I'm going to say probably not. That's kind of what the purpose of all of our recitations were for. The recitations were kind of like that in-person getting help thing. And unfortunately, there's no recitations this week because it's finals week, but I mean, there's also like not really assignments this week, so it's kind of goes together. Okay, what else is there? What about integrity? Any updates on the integrity? Is there any questions, I guess, about the integrity? I'd be happy to answer briefly a any questions about the integrity. Like I'm not gonna delve into the cases at all for academic integrity. But if there's a logistical question that I haven't answered still, I would be happy to answer that. Question, is the extra credit going to be up today? See, this is like the sorts of things when I say I got a lot going on this week. This is like a top priority. So my hope is to grind that out this afternoon, write up a nice little Discord parsing script to, pull that all out. I saw, maybe it was you that was talking about this good question thing. I completely forgot about that part of extra credit. It won't be that bad to parse that out. But unfortunately, as you noticed, or whoever noticed it was you. Yeah. We don't have a log for that, which means I'm going to have to go and parse the tab, but it's not going to be that bad. I'm sure ChatGPT will hold my hand through that process. So yeah, it's a matter of me writing some code to parse the Discord logs, blah, 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 do some sanity checks that no one was doing anything too insane with abusing extra credit, and go from there. So yes, my hope and desire is to get that done this afternoon after this office hours. Like that's basically next up on my to-do list. If not today, then definitely tomorrow. Like I agree, it's gotta happen soon here. It's just we got a lot going on this week, very unfortunately. Okay, so also as I'm taking some of these questions, I would encourage people, if they have questions about memory corruption, to start putting those in the chat so that I can have something that I'm ready to jump into for you guys. So I saw there seems to be a lot of demand and interest in this office hours to discuss memory corruption. I'm totally happy to talk about that. In fact, that's what I'm hoping the majority of this office hours will be discussing is, memory corruption / binary exploitation module that is due later today. Are the points getting cut for the entire module at particular levels? Yeah, so no PDFs to my knowledge were provided by TAs, but I'm going to discuss with my TAs to confirm that's the case. Are the academic yeah, it would be the entire module. Would you be able to talk briefly about stuff like IPython would be untraceable? So I didn't catch anything from IPython for this round of things. That being said, it's not untraceable, and I know how we're going to be monitoring IPython. It's really not that difficult, actually. But my analysis for this semester did not detect stuff like IPython. It specifically, I probably shouldn't be discussing too much, my methods, but it's basically had to do with files, only files. Okay, this one cannot be. Okay, so I see someone's got a question here about memory errors. Still confused about 7.0/7.1 for memory errors. Okay, let's see here. 7.0, 7.1, blah, 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 blah. Okay. Yeah. Okay, let's get out of this home face scene where it's just a giant picture of me and switch over to my desktop, because probably that's a little more interesting. That PS1 equals that, clear. Okay, so WinAuth address should be, I'm not sure what the WinAuth address should be. Okay, great question. Let's see if we can address that. We'll just jump into 7.1. Well, yeah, we'll jump into 7.1. Keep it simple. 7.0 should hopefully be a little bit easier since it, it talks you through it. And 7.1 is the same idea, it's just some stuff has changed. So let's kind of do the harder version to show how you really do this. Okay. Let's see here. Yeah, we got to refresh this, don't we? The heck is this? Okay. So if we run the challenge, we will see payload size. Maybe we're just kind of used to memory corruption. Certainly at the point where you're doing 7.1, hopefully you've spammed your fair share of A's before, and it looks like we got a segmentation fault. So that means probably, we don't know for sure, but probably segmentation fault occurred on a ret instruction in which these A's are overrode the saved instruction pointer, and so now it's trying to return to the address 0x4141411414. Hopefully that's kind of what's going on in your head as a likely cause. Now, memory corruption can manifest in all sorts of ways. It doesn't mean it happened at the ret address. It could have been a pointer we overwrote and then something tried to access memory from that and that sort of thing. But I don't know, maybe I'm biased because I've seen these challenges, and biased because, we're trying to make this a little easy, and we're generally focused on the idea of code execution. Probably that's what I expect to see. Now we can confirm that though, as it's really actually quite easy to confirm that. Here's what we're gonna do if we want to confirm that rather than just assume that. We definitely want to confirm things. It says payload size 100. Maybe I should have done 1,000 or something. Maybe 100 wasn't enough, but we can investigate this binary to confirm that. Okay, we do that, and we see we got a segmentation fault. So if we do x/8i to print 8 instructions at RIP, so my hypothesis in my head was correct. Obviously, I'm going to admit to you, it's a little unfair for me to claim things as hypotheses when I design these challenges, right? It's more really just a statement of fact, likely. But maybe some of you, and hopefully you had some sort of hypothesis here when you spammed your A's that memory corruption, certainly memory corruption occurred here if we have a segmentation fault, or the program is written really bad, but some sort of invalid memory access occurred. Hopefully I hypothesize one of those possible things might be that saved instruction pointer, which would manifest. You think to yourself, okay, I hypothesize it's the saved instruction pointer. I get a segmentation fault. What would be evidence of that? Well, evidence of that would be that the last instruction pointer is at this ret instruction. And in fact, that is where we are. Now, further evidence, if we really are like, but how do I really confirm this? If we want more evidence that we expect to see is that 0x4141411414 is at the top of the stack. If that's not the case, we still could have had memory corruption. Weird things could have happened, but it's not going to be immediately convert these A's into something else, and then we continue execution there. We might have more complications to our journey, but we'll be pretty happy if we see 41414 at the top of the stack. So if we want to do that, we can do x/1gx to print one giant word as hexadecimal, a giant word being 8 bytes in GDB land. And that would be $RSP to print the top of the stack. And sure enough, we see 414141414. Okay, hopefully no one has too many questions about that. Let's zoom into this a little bit. Okay, well, I'm happy to address some more academic stuff later, but we're gonna stick to this for right at this moment. Okay, so I'm not sure what the win auth address should be. So then, the natural question here is, well, what should I make this 414141441 be? There's a few questions here. It's like, what into all of these A's? Which sequence of 8 A's do I need to replace with something else that would correspond with these 8 A's, right? Because it's not like all of these somehow just like compress in some weird way and find themselves here. No, it's a specific sequence of 8 A's somewhere in all of these A's that corresponds to these. So that's one question, is like, how do we figure out which portion of these A's belongs here? And then the next and possibly more important question, though both are critical, is what should we make those A's be instead? Obviously, A's result in a segmentation fault. A segmentation fault is not a flag, at least in this challenge. It would be probably a cool challenge if we had that. I don't think we have any challenges like that. But we should figure out where should we go instead? And I think by the time you've hit 7, unfortunately I don't fully know in my head what the progression is up to 7, but I'm 99% sure you've seen some sort of win function before. So if we look at challenge baby mem level 7.1, I'm just going to use objdump. You could open this up in Ghidra, IDA, Binary Ninja, Anger Management, whatever. We're just going to keep it real simple. We're just going to use objdump pipe to less. And if I jump out to main, we're going to see that this exists. I've got a good feeling based on that question that there's a win or a win oft function somewhere in here. So really instead of main, what I'm going to search for is win. And I'm going to hit P to go up to the top and then N to search for it. And sure enough, just as the question alluded to, though it's hopefully not too difficult to find all the functions, right? We can just scroll. Well, I guess this has a lot of padding in here to randomize this a little bit. I mean, another way we could do this is the program NM will tell us all of our symbols in here. If we want to quickly look through our symbols, and we'll see somewhere in here, we've got like underscore start. We got this weird thing called bin padding. We've got challenge. We've got main. I don't know. Probably just grep win, right? I guess I saw it there at the bottom. Win auth. And I think if you look at the 7.0 version, it talks about this win auth thing. Okay, so maybe our initial thought would be, all right, we'll point it at win auth. Unfortunately, I'm going to tell you the reason it's called win auth and not win. It's you can't just point it at this function and you get the flag. Unfortunately, win auth has a little bit of a different behavior. So let's actually, we'll go ahead and make it so we can analyze that different behavior. I'm going to, just because I've seen some people talking about how IDA's decompilation server has been kind of out of commission for a few days. Unfortunately, we don't control IDA decompilation servers. Hopefully they didn't ban our IP address or something for too many requests. That would be pretty sad. Hopefully they just have some instability that they're sorting out. But in the meantime, just with that in mind, I'm going to jump into Binary Ninja because we've recently added their free version of Binary Ninja to the dojo. And I haven't really messed around with Binary Ninja a whole lot, but I've known about it for a long time, and I know that it looks super cool. Okay, so we're going to open, and we're going to go to challenge, baby mem level 7.1. We're gonna do this. We're gonna see if there's a way to zoom in a little bit. View. Window, plugins, window, edit, settings, fonts, maybe, font. Let's do a font size of 22. Did that do anything? Do I need to exit font? A little bit skeptical that that did anything. We'll go back to 11. View font size, 22. Does it not auto up? Oh, maybe that looks bigger. I go back to 11. Yeah, that's small. This has got to be bigger, right? Yeah, okay. Let's do 34. That sounds like a nice number. Okay, maybe that's way too large of a number. Let's just do 24. Okay. Cool. Let's roll with that. So what I'm going to do here, so this just lists a bunch of functions. There's a whole bunch of stuff you can do in these sorts of tools. I'm going to scroll here and look for WinAuth. Looks like WinAuth is right here. So we can see it looks like by default it's doing some sort of decompilation view. Binary Ninja has this idea of ILs, which I think is like intermediate languages or something to that effect, where you can just go straight to the disassembly of WinAuth, or they have what they call their low-level IL. Well, just kidding. That is not supported in the free version. That's also not supported. Really, you don't care about these probably. Probably all we really care about is that high level IL. You'll notice that this isn't valid C, right? We're like missing curly braces and stuff, but probably this is just like nice and readable. I don't know if it supports that. If you want your curly braces, you can have your curly braces and semicolons. Probably high level IL though, which was the default. You're going to be happy reading this. And what we're going to see, assuming this decompilation is correct, which, probably is not too difficult of a function. Probably we'll just kind of guess that it is for now until we're got evidence that suggests otherwise, or we're struggling a lot with the challenge. And once we're struggling a lot with the challenge, we start questioning all of our assumptions. Like one of those assumptions we're going to make here is this decompilation is correct. At some point, we're going to throw that into question and go straight to the disassembly or whatever. But for now, we'll add that to our set of assumptions that this decompilation is correct. And we'll see that it says there is an argument, and it says if arg1 equals 0x1337, then it prints you win. It opens a file named /flag. You see this high level IL is definitely not C, but it's kind of nice, right? It says like, it's telling us what the arguments are. That's kind of a nice syntax that we get to use, right? We got a file this, we got the flags this, maybe you forgot what the arguments to open are. Obviously you probably know open, but other functions, right? Like fd, we got buff, we got n bytes to say, hey, this is actually kind of nice. I like this high level IL. You can see this is like a little bit different than C. This is like a signed greater than. Often you might want to know that it's a signed comparison versus an unsigned comparison. This is a signed greater than 0. Then we write, we puts, blah, 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 else, blah, 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 blah. So the real important takeaway here is that if someone was to call win auth, or in our case, we're talking about memory corruption, control flow hijacking, and diverting control flow off to win auth, it looks like we would need an arg1 of 0x1337. And you might be thinking to yourself, well, I'm like retting to this thing, right? I'm not calling it. There's no point in this exploit do I get to do call win auth with this argument or something. I just like set the saved instruction pointer to this address, and suddenly we're executing here. And if we think about like this kind of in your head when you're thinking about this sort of stuff, you're kind of constantly be going between like very low level details and high level details, like simultaneously in your head. And in your head, is it just a skill you build up? And this is why we do this challenge-based learning. In your head, what you're hopefully starting to think, or you're going to develop the skill of thinking, is that arg1 isn't something special. There's nothing magical about arg1. Arg1 is just, at this point in execution, the register RDI is some value, and that some value RDI is the argument. So if somehow magically, let's say, RDI was able to be set to 0x1337, win auth would function the same as win, right? We can think here, if we go off to GDB land again, and we'll run it, and we'll say 100 and give a whole bunch of A's. And we continue x8i. Did I lose it because I accidentally hit continue when that's not really what I wanted. We already seg faulted. Don't hit continue when you already seg fault. The program is truly gone now. Run it again. 100, bunch of A's. And if we look at where we're executing, right, we know what we're going to see. It's going to be this ret instruction. Unfortunately for us, or maybe we're really lucky, let's see, what is the value of RDI right now? This is going to be the first argument, effectively. And it looks like it's this value, right? So what that means is if we return here, this just isn't going to work because RDI is not 1337, and so this will fail. If by some miracle this had been 1337, we could just return to win auth. and everything would be cool. Or if there was some way that we could control RDI. Turns out there are really cool, fancy ways of controlling something like RDI where you actually don't return to something like winauth. First, you return to some little snippet of code that modifies RDI, and then from there you return to winauth. This is like you might be thinking like, how the heck do you ever manage to do that? This is like an entire classification of exploitation technique known as return-oriented programming, which we don't talk about in this class, but if you're interested in, it's really cool, take 466. There'll be a whole module on return-oriented programming where this issue of, well, we can't be 1337, what the heck do? We will teach you how to overcome that limitation. It turns out it's actually not that difficult. It's exactly what I just told you. But in this case, we're kind of fortunate. There's another technique here that we can abuse. And what we can abuse is if we look at, we'll just say disassess winauth. What you'll see here, right, this is just a bunch of instructions in a row. So in our head, we're looking at it as like this high level description, but in reality, I mean, it's nice to think about it as that high level description, but the more fundamental truth is that it's just a bunch of these instructions executing sequentially or, with control flow moving around, but you get the idea. And somewhere in here, right, if we want to do this, somewhere in here, we need like a jump if not equal or jump if equal with a comparison or some sort of thing that's going to make this comparison occur, represented as x86. And you'll see right here that this is exactly that, right? Compare RBP minus hex4 with 1337. And you might be thinking, what the heck? I thought you said RDI. What is this? This is not RDI. Well, look one up, right? They decide to, in this case, put the 32-bit version of RDI EDI into this location in memory and then compare with that. Why does it do that? Well, we're running unoptimized x86 code. We use GCC. It does things that it probably really doesn't need to do. It decided to persist this. You might be thinking at some point later on in the function, we might clobber EDI, but we still might want to refer to that argument. This is kind of just like if you're going to write a compiler, which is just a thing that takes some source text stuff and starts emitting assembly, the simple thing to do is if someone needs to refer to that thing later, just right at the beginning, save it somewhere. And then you don't have to worry about this thing, you just always refer to this thing, right? You got infinite-ish stack space, you got limited-ish registers, or not even ish, definitely limited registers. And so you'll see all this occurs, and this says that if it's not equal, so if it's not equal to 1337, we go to winauth plus 270, which winauth plus 270 is right here, which I guess goes to winauth plus 274. Why does it want to jump over this knob? Truly, I don't know. I don't know if this is some sort of alignment requirement. Sometimes there's like this weird thing of alignment that we haven't talked about in this class, and we're not really going to talk about. Maybe it's just back to kind of not running optimized assembly and it just kind of doing its thing. I'm really not totally sure what mechanism convinced the compiler that it wanted to have a NOP here and then jump past the NOP. I don't know the answer to that one, but either way, it makes its way to leave ret. That's kind of the important thing. And so we're talking about this being the beginning of this function, right? This 3F7 ending address. And we're talking about, replacing those 8 A's. If we zoom back out, replacing 8 of those 100 A's with this address represented as a 8-byte little endian integer. And this would be like if it was with the win function, you would do something like that. But unfortunately, this is not the win function, it's the winauth function. Well, here's your extreme hint that I'm pretty sure 7.0 talks about, but hopefully this long form explanation of it helps a bit. Just don't return to this address. Just skip past this. You don't want to execute this? Don't execute it. Just go right here, right? Or actually not right there, right here. We don't want to even think about what's going to happen here. We just go straight here. and we're good to go, right? Now, this is a little bit dangerous, jumping partway into a function. The danger here is that we will not have set up our stack, potentially. There might have been important stuff that happened in these instructions that I'm telling you to just skip over. And if that's the case, you're going to have issues, right? For example, if someone now refers to RBP minus hex 4, well, we never set up our stack frame where RSP goes into RBP and this sort of thing. If someone starts referring to RBP relative addresses, we did not create a new stack frame. This is going to be relative to where we did our ret from, whatever RBP was here, right? At this point in ret, RBP is some value. And if later down the line, someone starts referencing an RBP thing, that could get crazy. Fortunately for you, the only thing that gets saved onto the stack is that first argument. And if we look at this, you'll see that that first argument is only ever referenced right at the start. Everything at this point and onward is going to, I believe, be all RIP relative. And that is just going to be wherever you're executing regardless. So we don't really care about the dangers of that. Everything here should be able to execute just fine. I'm noticing this looks scary as another thing that isn't RIP relative. This is from RAX. Where's RAX coming from? Well, it's just coming from like over here, flag, FD, blah, blah, blah. You're going to be all right. Oh yeah, that's right. In fact, I think we made it so that we wrote this function to be very generous to you, that you might think like, well, what happened when I open the flag? Where does the file descriptor get saved? If we read this code right here, what this code says, and maybe it's not intuitive yet, but hopefully you start to build up a little bit of intuition here, that this is not an RBP relative thing that we're moving EAX into. So the file descriptor return from open is not going to an RBP relative thing. It's going to a RIP relative thing. And a RIP relative value for saving, like, right, what's going to come out of here is like the number 4, file descriptor 4. This is going to this RIP relative value. Where this is really going is it's going to global memory. So that what that means is that this function is implemented using global memory. Let's see if Binary Ninja, yeah, you can see Binary Ninja kind of picked that up. Maybe a little bit at least. I don't know. Like, what's an example of a function? Let's see if we hit G, or actually right here. Yeah, you can see right here that it kind of pre-declares variables, right? If it wants to say that these are stack variables. So if someone starts talking about var68 in this function, or var50, this is a stack variable. It looks like this right here. Maybe if I double click on it, I'll see something. Yeah, this is often like global memory. So it's kind of a little bit of a weird choice to do that, but it turns out it helps you a lot. Okay. Let's see here. Let's make sure we're, to get the memory address before calling the window, I first break and then run the print. Some people are saying IDA is working against. Feel free to use IDA. For your purposes where you're just getting first exposure to this, really none of these matter. Really, you could get away with just using objdump and looking at the disassembly. I know most of you are going to say, absolutely not, I will not be doing that. But I'm telling you, it's really not that bad. You want stuff like IDA when you're analyzing like massive programs. Okay, like if you want to go and reverse engineer proprietary Google Chrome stuff, blah, 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 right? Chromium's open source, but maybe, or like some firmware blob or massive complex thing, right? This is where you start needing more sophisticated tools to really help you. Even then, I mean, there's no reason you need it. It's just, it helps. Okay, so let's see here. Moving around here real quick. All right. So, yeah, exactly. Okay, someone's asking, how do I get the address then? So hopefully, I think I just showed you how you get it, but well, okay, not true. So we have a little bit of an issue here, even still. So Do we have an issue? I think we have an issue. Here's how we know if we have an issue. Actually, I think the description tells us we have an issue. You'll see, but this time in a position-independent binary. So here's the issue. And I think I talked about this a bit in my last office hours, but I'll discuss it again. If we go to winauth, you will see that this is the address of winauth. Just kidding, though. That is not the address of winauth. This is the relative address of winauth. At program start time, winauth, there will be some page address selected. Page meaning, let's talk about the last three hex digits are zeros. There will be some location picked that's moving around every time you run it. And winauth will be placed at offset 13F7 from that selected location. So if we GDB this and we start and we look at winauth, nope, that's not how we're doing that. XGX, yeah, whatever, good enough. Kind of weird to print it this way, but we'll see, right, that there's this 3F7. And let's create a new terminal. And obj dump this winauth 3F7. This part, though, not what that says, right? This is way over here. This like 55EF5B33. Blah, 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 blah. Let's even save this for the moment. Create this. So this is the current address of winauth. Let's run the program again. What the heck? XGX winauth. Guess where it is this time? Right here. Notice these are not the same, right? 3F7 is the same. You'll notice some things happen to be the same, right? It starts with a 5. Sure. This is the only thing that's the same, though. This all changed, okay? This is randomized every single time. This is what's known as a position-independent executable. That means is that this code has been compiled such that it does not care about its address. It only cares about its relative address. And in that way, it is position-independent. And so we do not know the address because this is going to change every time, which means that, you know, under normal circumstances, when I'm sending an input, effectively what I got to do is I got to do something like this. Like you might say, well, just figure it out in GDB, right? Which sure, you're thinking that's fine, but that's not actually going to work because at some point I got to do something that looks like this, or really, you know, we got to specify a size. So we'd say like 100 and E to make it so there's no new line, and it, I don't know what E stands for, but I think that deals with this sort of thing. And in doing it in this way, right, I don't get to analyze the program to see where it's decided to place this address when I want to interact with this thing for real. If I try to solve this while using GDB, what that means is that this program is not running as root. If I'm able to interact with it in a debugger, I can assure you that this thing is not running as root. And so you can't just go and use GDB to figure out this address. All we really know is that whatever the address is, that it ends with 3F7. That's all we get to know. Okay, hopefully that is clear. There is fortunately a solution here. So that solution has to do with, I think I talked about this also in my last office hours, but I will reiterate it again. That solution has to do with what's called a partial overwrite. So I'm talking about here when I use GDB, right? As we've already seen, I'm going to run it again, a bunch of A's. Right, we gotta constantly be shifting our focus in how we think about this while simultaneously keeping all these ideas in our head. Okay, we gotta keep a lot of ideas in our head at the same time. And hopefully everyone's still with me on how the heck this is all going down. Right, we've got a ret instruction critically at the top of the stack. is these 4141414s. These 41414s come from somewhere in this long string of A's. I don't know exactly where. We can compute where. It's not that hard to figure out which section of A's it is. But that is why there are all of these A's right here. If we run this again without memory corruption, and in order to do that, I'm going to actually break. I want to see, I want to see this right here. Break at challenge plus 254. I'm going to run it again. Let's not do memory corruption. Let's just say our payload size is 4, and I send 4 A's. Okay. I'm now at this breakpoint again that I've set for myself. We're not going to crash, right? Because we're not doing memory corruption. We're not going to crash, so we're not going to get a segmentation fault and automatically get a breakpoint here or something. So we got to set that breakpoint ourselves. What's now at the top of the stack is a normal value. It is this thing right here. And what is this thing right here? Well, this is going to be, hopefully, constantly be making hypotheses in your head. What is the evidence that confirms that? If that's not true, that would mean you're thinking about this wrong. Constantly fact-checking yourself in this way. This address should be partway through main, some offset into main, and specifically the address right after where main calls challenge, because somewhere in here, I know we didn't do the full analysis, but when you're doing this for yourself, somewhere in here we have the challenge thing. And if I hit, it's X work here, I guess there's code references here. So challenge gets called by main. If I'm looking at this bottom left, it's kind of every one of these tools does things a little bit differently. I kind of like this style of Binary Ninja to just always be showing you your cross references. And a cross reference basically just means someone references this thing. And specifically, main references challenge in that the way that it references it, it's a cross reference. The way it references it, it calls it. So main calls challenge. You might think the more generic thing is you might not necessarily have a code cross reference. You might have like a data cross reference. So there's still a reference. And in this case, main calls challenge. So what that means is I'm expecting right here, this address on the stack, just another little, fact check for myself, make sure that I'm keeping up with what's going on here. It should be pointing at the code right after challenge. And if I want to know exactly where, maybe we'll go back into disassembly. It should be pointing at something that ends with 6F8. Is that what it said? 6F8? Yeah, look at this, 6F8. And if we specifically look at these instructions, right, GDB tells us, yep, sure enough, partway through main, specifically at this leave ret pairing. Okay, cool. So that is the normal behavior. And as I talked about in my last office hours, I could send enough A's because we've got a lot of concepts simultaneously. What is this thing that I printed out? XGX-RSP, this thing, this is a value. This is our saved instruction pointer. It's a value somewhere on the stack. So it's on the stack. It's at the top of the stack at the point that we're doing this ret. We're just doing a pop RIP. That's what a ret is. We're popping into RIP. Right at the top of the stack is some value. What is memory really, right? It's just a sequence of bytes. We got a sequence of bytes, not a sequence of 8 bytes at a time, not 8-byte chunks, sequence of single bytes. And the way that we represent an 8-byte integer is as a little endian integer. We represent all of this stuff as little endian integers. And so if I look at this, we're going to see it's backwards. The very first byte will be F8, then 76, then 50. Here's how I can print it as, instead of printing it as a giant word where we get to kind of take that little endian and like parse it into a hexadecimal value, right? I could have also, should point out, printed this instead of as hexadecimal, I could print it as decimal. I don't know why you would want to view this address as decimal, but you could, right? It's just a hexadecimal value, it's a decimal value, it's all the same thing, just a different way of viewing it. We could also, though, view this as 8 individual bytes, 8bx. And what that is first byte is an F8, 76 is the next one, right? Again, we don't have to view it as 8 bytes. We can view it as 2 bytes if we wanted to. F876. It's our choice to think that 8 bytes matters. And it does, of course, right? We're doing an 8-byte pop. And then 50 and so on. And so when all of our A's come through, right, if we look higher up on the stack or further, I don't know what exactly the right terminology might be there. If we look at RSP is here, if we look further down at a lower address on the stack, let's look 100 below RSP and print 100 of them, right? We sent 4 A's onto the stack. So we've got 41, 41, 41, 41. When we sent those A's, this was the first A that well, is that true? Hold on. Let's make sure we're not making stuff up. RSP minus 100. No. Let's not overcomplicate this. In fact, let's print 108 bytes. Or, hold on, the issue is I'm not specifying a number that's a multiple of 8. We really want a multiple of 8. I think 104 is a multiple of 8. Yeah. What we have here is A, and then more stuff that's just the stack. And then, actually, I think we want another 8. Okay, and then if we XGX RSP to remind ourselves, right, somewhere in here we have F8. So let's look at this. F8. F8 is right here, followed by 76, followed by 50, followed by 02, right? This is all corresponding to this value just backwards. The very first thing is an F8. Then the second thing is the second least significance of 76, then 50, blah, 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 blah. Right? It's just coming through this way. And so I know it's a little bit weird because it's fragmented. This is the first 4 bytes of my 8-byte little endian integer. This is the last 4 bytes, right? So it's this, I can't do, I can do that, but obviously not the address. So this right here is my saved instruction pointer. This is my input, these 4 A's. If I had sent an additional 8 A's, those 8 A's would go through here, and then another 8 A's would go through here. And let's actually, well, we're not going to immediately show that. Well, we can, whatever, why not? Let's do, we'll say it's 12 bytes, right? We'll say 4 A's, 4 B's, 4 C's. Okay, 12 bytes. Okay, I'm not making this stuff up. Let's print our stack again, right? So now we've got 4 A's, 4 B's, 4 C's. We're slowly making our way at, right? This value is the first value that's really going to hit us hard if we mess with this, because this is our control flow value. This is our saved instruction pointer, the first byte of our saved instruction pointer. So when I send a bunch of A's, those A's just keep coming, crashing through here and overflow through all of this. We don't need to overflow through all of this though, for what I'm talking about, because we don't know what to set all 8 bytes to, right? We said every single time, again, lots of concepts simultaneously. Think back to this part. Oops. We don't know what 8 bytes to send here, because we just don't know. But we do know the first byte, right? We know that we want it to be an F7. So if we look at this, if we do XGX RSP, that is this value. And if we look at win auth, or we'll just do an XGX win auth, that is this value. So let's actually even copy this into my notes. So this is what it currently is. And this is what we would like it to be. And I said we can't send this whole thing, but look at this. The first significant portion that we don't know is already correct, right? Looks like all the way up through here. So it looks like just these 2 bytes, because remember this is a byte at a time, 2 hex characters. I want to turn this F8 that is currently here into an F7, because that's where my win auth is. Actually, hold on, not true. Another thing we got to remember, we decided for ourselves we don't actually want be at the start of win-auth, I said something to the effect of, well, no, actually, we would rather be partway through win-auth because we discussed this 1337 thing. We would really like to be over here. So jump not equal win-auth load effective address. Yeah, we'd like to be over here. So we'd like to be at this address, actually. What are we? Is it the F7? F7, yes. We don't actually care about this guy. We care about this guy. But just as before, right? This part is already correct. So what that means, if we look back at our stack, okay, this F8 and this 06, this F8 and this 06, that is what's currently there. These are the only bytes we need to change out. 9A, 6D, DC, and 55. These are values we don't know what they're going to be each time we run this program. It's going to change, but they're already correct. Don't touch them. These 2 bytes are the only bytes we need to change. Now, unfortunately, the thing I told you earlier is that what's randomized every time is this. What that means is this byte is partially randomized each time. So this will never be randomized. We're good on this guy. Okay, the least significant byte is chill. And then the next 4 bits is also chill. The least significant 12 bits is chilling. And the reason for that is that a page is hex 1000 bytes and it's page randomized. So these zeros, a page is hex 1000. These zeros they're never changing. This is always going to be correct. The page, though, is changing. And so we could easily imagine ourselves sending a bunch of A's or whatever all the way up to this F8, right? So our last A we sent was right here. And then instead of an F8, what we want it to be is a 1-3. So instead of an A, the very next thing we send is a 1-3. And that would clobber this F8 into a 1-3. That's not exactly the address we want, though. If we think about that, right? Then we would have what would be our saved instruction pointer would be this becomes a 1-3. So we would be looking here. So if we replace that with 1-3 like that, we would return execution to right here, which is a thing partway through main, near the beginning of main. So the program would like possibly just restart itself, which is kind of interesting. But that's not what we want. We want to be partway through win-auth. So we also need to change this into, ideally in this case, it's a 0-4, but this 0 here is going to change every time. What we can do, though, is not an issue. We can send 2 bytes. We can send 0-4. So this byte right here, we send as a 1-3. And then this byte right here, we send as a 0-3. So we have a bunch of A's and then those 2 bytes. And 1 out of 16 times will be correct. Is basically what I'm going to tell you, right? So this 0 could be something. It's going to be different every single time. But there's only 16 values this 0 can be, right? It's a hexadecimal digit. There's 16 hexadecimal digits. It's 4 bits. There's 4 different values it can be. So you just keep rerunning the program with your exploit, and with a 1 in 16 odds, you'll be correct. So you just keep rerunning it, eventually hit it. A 1 in 16 brute force, very small, totally cool. And so that is how you account for that. Okay. Cool. Unfortunately, no Zoom calls after this. Wait, how did you get the 0413 gain LOL? 0413. So this 0413, so as we said, so F806 is what's already there, and it's going to be there, you know, at least this F8 will be there every time because this is partway through main. This is right here, right? We call a challenge. So the next place is going to be this F8. And that's why that is currently F8. But the other value, win-auth, where did I get that from? Well, I get that from the fact you, as we said before, you could imagine going to the beginning of win-auth, in which case you would want an F713, right? You could do an F7 F7 13 or whatever. But that is not actually what we want. We want to be partway through this function. We want to be after this comparison and after this jump not equal. After it checks to see if RDI is 1337, we just want to jump straight to the part where it's you win. We don't care about this comparison stuff. Let's just skip past it. In which case we want 1314, right? That's what it's displaying to us here in Binary Ninja, 1314. I think I wrote that backwards. 1314. No, that's correct. 1314, but of course we'd be sending a 14 and then a 13. Wait, is that true? Hold on. I feel like I'm losing my mind here a little bit. Yeah, I did write this backwards. Okay. Little endian integers, right? We're not writing it backwards, we're writing it kind of what we'd be used to. The least significant byte is a 13, right? That's what we're saying. And then 14. And of course, as you're saying, I'm telling you, send it a bunch of A's followed by a 1304. But Binary Ninja is like almost seemingly telling us to send a bunch of A's and then a 1314. Right? This is the digit that's randomized, though. This is randomized. So you could, in fact, send a 14. You could send, oops. If you really wanted to, you could send a 2-3. Or you could send a 3-3. Whoops, hold on. Not true. Little endian integer. This one is always correct. The 13, the least significant byte, always. This you could change, right? You could change this to a 2-4. The second least significant byte. This digit right here changes every single time we run it. All the way up to the possible values is F4, right? There's 16 possible things. Every time you run it, there's 16 possible things that this digit might need to be. So you could pick any of them. In my case, I like to reassure myself by the fact that in this particular execution of running it in GDB, in this particular execution, we have seen a moment where it is 0413, and that makes me feel good and warm inside, right? That the fact that we've seen a particular instance of this value means that we could see it again. So I like that one. I like to do it in GDB, see an address that it actually is at some point in time, and then just wait for my 1 in 16 for this to occur again. That is how. So the 04 F7 part gets randomized. Hold on, let me copy this. Okay, so the 04 F7. 04/F. Yes, exactly, correct. Yeah, so this byte right here, the second, so this is the least significant right here. If I can spell significant, right? This very last value is the least significant. That is not randomized at all. Second least significant right here, right? As we walk bytes all the way up to like the most significant here. I mean, technically there's zeros in front, but whatever. The second least significant byte, this is partially randomized. This guy right here is fully randomized. If you wanted to guess this, this is a 1 in 256. This guy is actually a 1 in 16 because this 6 does not change, this 4 does not change, this 7 does not change, this 4 does not change. It's just this part that's changing. Now, unfortunately, there's no way to interact with the program over something like a read system call and only send 4 bits, right? Everything operates at a byte boundary. If we could somehow magically send AAA 13 and then like I'm writing technically the next least significant bits with the 4 would be the next least significant bits here, right? If we were to think about this, if it was somehow there was this magical way if you could just send a bit stream instead of like a byte stream, then we'd be cool, right? Because all we care about is then these next 4 bits, and then we could just leave the next 4 bits empty. But there's just no way to do that. Everything's at a byte boundary. And so you got your 1 in 16, just run it multiple times. Otherwise, exactly right. Is there in-person office hours? So in this course, we have every single week, we have had every single day in-person recitations for discussing these challenges. There will not be in-person office hours this week. There will not be in-person recitations. We're in the last week. It's finals week. The last assignment is due today. Possibly I'll run another office hours to help people with these challenges. But I will not be doing a Zoom call or in-person office hours, etc. If you're discussing academic integrity stuff, read the notice, go through the dispute link. That's how we're going to be processing everything. If you do have further disputes, so continuing on my discussion here with academic integrity, if you do have more disputes, that's totally fine. I, on Wednesday, will decide what I'm going to move forward with. That doesn't mean you're absolutely confirmed to have the case or whatever. That just means that it's moving forward with the academic integrity office. At that time, if you choose, this basically what's going to happen is I'm going to submit on the order of 350 notices to academic integrity. If we discover through the dispute process anything that we don't want to move forward with, we will drop those just immediately. They'll never even hit academic integrity. But when we do decide on Wednesday what we're going to move forward with, that's just who I am informing that I believe I have evidence for. At that point, academic integrity will reach out to all of those students with some sort of email, and something in that email will say something to the effect of, if you'd like to get this just done and over with, you'd like to confirm that this is in fact what happened, please just respond here and say, yep, that is in fact what happened. Before the deadline for grades to be pushed, the academic integrity office will submit all of those students and basically say, hey, give a 0 for this assignment, give a 0 for this assignment, give a 0 for this assignment, 0 for this assignment, etc. The academic integrity will send that all to me. I'll process that into our grades. Your case will be closed, etc. You don't have to do that though. If you decide that you'd like to discuss this further, get heard more, etc., totally, there's due process within the academic integrity process. At that point, they'll set up an unclosed case file, right? They won't close out your case. You will receive an incomplete in the course as we figure out the situation. I believe I talked with them and they said that they don't normally process cases over the summer. What that means is that your hearing, or I have no idea what the correct terminology is, right? Your discussion period for this situation will likely occur early in the fall semester. At which point you'll be able to further discuss this with me, further discuss this with the more neutral, right? If you don't trust my neutrality on this, which fine, whatever, you'll be able to discuss this also with the academic integrity office. I will say though that I'm submitting very confident evidence. It's very unlikely that anything will happen on that day other than a 5-minute meeting with something to the effect of, this is what you did. We believe more likely than not that this is evidence of academic integrity, right? The standard is something to the effect of 51%, right? Someone would likely believe that this is the case. We'll move forward, blah, 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 blah. But you will have an opportunity, of course, if you want to dispute. I will not, though, be doing in-person office hours to discuss these cases. There's 350 of them. It's just not going to happen. Or Zoom. The only thing that I will be accepting for disputes is the dispute link. That's how we're going to process this. If you want to have that 5-minute discussion in the fall through the academic integrity office process, probably I'm going to be sitting in a room for 4 hours, processing students 5 minutes at a time. I'm going to do it, right? But that is where you will have your opportunity to discuss it with me in person, but just realize evidence is very strong. If it's not dropped before it goes to the academic integrity office, I wouldn't really count on that being a real time to change opinions here, but it will be, another opportunity, and you will have me in person. Okay. Dispute gonna be to AIO. I don't like. AIO will process your case after I submit them on Wednesday. But ultimately what they're going to do is they're going to pull me back in to say, hey, do you think that this student is more likely than not cheating? And I mean, at the point that I'm already submitting you, I'm probably just going to say yes to that. But you'll have the opportunity for that to be processed by them in some sort of due process way. I don't know their process truly, but this is what has been communicated to me so far. If we submitted a dispute form, would we know if it was rejected or not on Wednesday? Yes, if I, well, okay, let me say it this way. If I decide not to move forward with your case, I will inform you. If I decide to move forward with your case, I will not inform you, but academic integrity will reach out to you probably Thursday or Friday. I will inform you if your dispute makes sense and I'm not going to move forward with it. I don't know. Yeah. So I'll let you know if I'm not moving forward with your case, because otherwise you're not going to receive any information. But if I am moving forward with your case, academic integrity will reach out to you. If we dispute, is it going to be taken to AI? Like, am I going to submit your dispute as well to AIO? I don't know. If it makes sense to, I might. Yeah. Why was this? Unfortunately, this is when I discovered this information. Yeah. I would have preferred, of course, to have discovered it earlier on, as I'm sure you also probably would have preferred to discover it earlier on. What is under dispute? So this is, the discussion is for spring 2024 CSE365 at ASU academic integrity stuff. Yeah. Not relevant to the assignments or pwn.college learning stuff, if that is what you're here for, which I understand that's what you're here for. But unfortunately, we have a lot of students this semester that have concerns about this, so I figured I would discuss it here since I'm seeing a lot of questions. For the assignments being cut, would it be possible to lose points on the individual levels instead of the whole module because of how late we received this information? No. I mean, I'll do whatever the academic integrity office says. So the way that it works is I say, I have this evidence for these assignments. Assuming they say, yep, we agree, they'll say something to the effect of, please assign zeros for these assignments, right? So the academic integrity office is responsible for assigning the consequences. So for first-time offenders, the whole module, the whole assignment becomes a 0. For second-time offenders, I don't fully know the process. My understanding is you get an E if you're a second-time offender, but that'll be kind of something you got to figure out directly with them. Okay. Does anyone have more questions about academic integrity or about memory corruption? I'm also happy to dive into another discussion of memory corruption because, you know what? Those of you still working on the assignment, right? We still got 13 hours on this assignment. So I'm going to give a little more priority here to discussing the module over academic integrity. Hopefully my notice is kind of clear. I also discussed a lot of this immediately after the fact in the Discord. So if you search for my name in On Topic, I answered a whole bunch of questions immediately after I submitted it, which I don't think there's anything that wasn't actually just also in the notice, but if you're curious if there's more information, go ahead and search there. Will the dispute submitted going to be sent to AIO and the case becomes unclosed? So technically this has not started yet with academic integrity. On Wednesday, it will officially start with academic integrity so that your case will open on Wednesday or Thursday. I don't know whenever academic integrity gets around to it, at which point it becomes an open case. At that point, they email you. You have the opportunity to just immediately close the case by agreeing with what I'm alleging. Alternatively, you can choose not to do that. It's your right to do that. I would not encourage it. I don't think things are going to change in any meaningful way at that point, but you have the opportunity to not close the case immediately, at which point I don't fully know. I'll talk with academic integrity, but my understanding is at some point, probably early next semester, we'll have me sitting in a room for 4 hours processing cases very, very quickly. Likely it'll be something to the effect of, I'm sorry that this is your circumstances, but in fact, we do have evidence that makes us believe that this is more likely than not, and you'll have your moment there to quickly chat, but it will be closed pretty quickly there as well. A bit off topic, but do you know when 598 AVR gonna launch? Oh, is it not launched yet? I do not know, but I've heard a lot of talking about it, so I'm highly confident it will occur. I just don't know when it's gonna launch. Right now I'm thinking grade curving is gonna look something like a 60% for a C, but I haven't fully decided. Right now it's 70%. I'm thinking 60. I'm not confirming that yet. I will announce in the Discord my official or our course's official curve at some point, though. I'll make sure that everyone is well aware of what the curve actually is. But if you're worried about your grades, solve more challenges or get extra credit or whatever. Let's consider, what if we lose the case? Does the sanction get worse or remain the same? Truthfully, I mean, it's a lot of students. So, I mean, one of the things I discussed was how do we make sure that we don't overwhelm the academic integrity office with people trying to dispute it? No, it's a due process, right? Your sanctions won't be worse. It'll remain the same. That being said, don't think of this as like your last ditch effort. Like, realistically, from what I have been told, this is not really, it's almost like they're basically asking me if I believe you did it. And if I've already submitted the evidence thinking you did it, things aren't going to change, right? Like, you're more than welcome to try and not immediately close your case, but I don't think things are going to change for you. Yeah. I'm trying to be as considerate as I can. It's just, there's a lot of people. I'm trying to be as considerate as I can through this. Okay. Unfortunately, I have to keep the integrity of the course. When will we know the official curve? Probably Wednesday. If I don't have it to you by Wednesday, I would feel free to bug me. I'll definitely make sure it's before the weekend in case, you want to hear what that final official curve is and work on challenges during the weekend, blah, 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 blah. I'm still considering a lot of things for that official curve. That's why I don't have the immediate answer. I'm feeling pretty good about a 60% as that C threshold for passing, but I'm not committing to that yet. And if you're concerned, I highly encourage you to solve more challenges. Solve more challenges, solve more challenges. No, May 2nd is not the last day. The last day is May 5th. So according to the syllabus, take a look at the syllabus. May 5th, end of day. That is when it's due. Will the A boundary change? The A and A minus boundaries will likely, so if there is a curve, the A and A minus boundaries will likely change. So for example, something that's, I guess full disclosure, like something I'm thinking about is like, what was it? Like 90% for an A minus, 85 for an A. And I think it's basically just step down 5% for every letter grade. And I think that lands you at a 60% for a C. A plus will definitely still be 100%. But if there is a curve, probably there will be a curve for all the letters, not just that C. A plus is not being curved though. But probably the rest will be if there is a curve. What is your view on the PDFs and students? Like, students cheating with PDFs want to know, for your exec POV to have a better understanding on the upcoming allegations. Yeah, I mean, so my best understanding of what occurred is that people documented a bunch of solutions to this course with PDFs. Likely you found this PDF somewhere online through, you know, the classic cheating websites, or, you know, like the Chegs and those sort of things. You know, you say study resource, right? But we all know what that actually means. I mean, it's just like very blatantly, obviously, like it's a solution walkthrough for all of my challenges, right? It's just like, it's not an educational resource. This is just undisputably going to be if you and you could say, oh, I already found the PDF, so this is not a student for. I found a PDF that walks through every single challenge and like step by step, blah 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 blah, for the things that isn't just copy and paste. Like I think I already found, it's an over 100-page PDF, if that's what you're discussing. I think I've already found it, and this is in fact the primary thing that I've gone after for searching. Not the only thing, but the primary thing. I've made it very easy to find all of these cases, or almost all of these cases. So if you're thinking to yourself, like, I'm going to dispute this on the grounds that that PDF, I didn't think that was a cheating resource. I mean, it's just undisputably, like, yeah, I don't think any instructor or average student under these current allegations or the Academic Integrity Office would dispute that this is undeniably a cheating resource. Why would someone let it out for free? I have no idea why students or whoever let out cheating documents for free. I don't know, probably for feeling good about fighting the man or something. I really don't know. But it's, I mean, if there was any question, and at a bare minimum, anyone that had this PDF should have at least had a bare minimum question of, is it okay for me to be using this? And not a single student asked me that question, or any of our instructors. Like this, at a bare minimum, it would be like a questionable thing. I think it's outright obvious what the status is of that document. But at a bare minimum, there should have been a question, at which point someone should have asked something, right? It's like, I think it's pretty clear. Okay, anyways, I saw there was another question that I should get back to. I'm working on the very last flag right now, and I'm having trouble figuring out the inner details of the assembly/disassembly. Okay. So I'm guessing you're talking about program exploitation 2.1, maybe, Ben Max. Let's see here. I guess I'm curious for your question here, figuring out the inner details of the assembly disassembly. If you could be a little more specific about what your question is, in terms of, is this a question of like this injecting shellcode part? Are you trying to analyze the challenge program itself? Actually, let's start up the 2.0 version. That way we can see, it'll discuss what the heck's going on in this challenge. Inner details of the assembly, disassembly. Inner details. Challenge this. Okay, so this talks about a whole bunch of stuff. We got kind of the 3 sub-modules being brought together here. Or is it 3? 2? 2, maybe 2. I don't know. Either way, we've got this coming together. And what this is going to talk about is we have our stack pointer, our base pointer, blah, 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 blah. There's a lot of information, but if you're confused about what's going on, I encourage you to read it. It is useful information. The input will be read into this buffer. The buffer is 59 bytes long. Previous challenges have said similar things. We have disabled the following standard memory corruption mitigations for the challenge. The canary is disabled, so there will be no canary. The binary is not position independent. So in the previous challenge we looked at in this office hours, we looked at a position independent binary, which caused this whole, thing. It's not position independent, which means we can just send all 8 bytes. We know what all 8 bytes need to be, just send them all. Located at the same spot every time it is run, which means you can use like objdump or IDA or Gija or binary ninja, and it'll just tell you the exact true address that you might not want to use. Binary will disable ASLR. So this isn't something we've talked about a whole lot in my office hours. But ASLR is very similar to this position independent idea. Instead of our code addresses though, right, where the addresses of our code, our assembly, being randomized, what ASLR has to do with is the stack itself being randomized. So this is saying that the stack will not move around. So when I'm in GDB, I was doing like print x RSP, or specifically xgx RSP, to look at what the saved instruction pointer value was. It was also printing out like the stack value. And so what this is saying is that's not moving around. It'll always be at the same location. And then this is like the big one. The stack is executable. So if you can get data onto the stack and move it so that, or move your saved instruction pointer to point at the stack, rather than like a code page, like literally just a stack page, the stack is executable. If your shell code or your code is there, it'll just start running code there, which is pretty cool. So let's say 100, I send a bunch of A's, and this is what it says. So I've sent 12 bytes. We can see 8 A's followed by another 3 A's. So that's 11 A's followed by a new line character. And these bytes here, these are like real special bytes. Normally these bytes we're putting here are like A's and then like also like addresses to some code, right? So like addresses to the win function, for example. Now this program doesn't have a win function. If we do something like, when we grep for win, we will see there is no win function. There really is not one. We didn't like obscure it or something. There's no win function. So that means right here, this location right here, this is our saved instruction pointer. And the challenge says as much. So we've got a saved instruction pointer, and that saved instruction pointer previously to main is at this right here, right? This 288, and it is pointing at 401E39, so 391E40. So this right here is the saved instruction pointer. So as we discussed previously, we could start sending a bunch of A's and we could smash right through the stack all the way through here. And if we send enough A's, this program would segfault. So let's even just show that. Let's not claim it, let's show it. So 100, let's do a bunch of A's. And we will see what happened, bunch of A's. Something decided to overwrite some of those A's, right? So something was saved here. Probably, just looking at this, so hex 64 is decimal 100. And we sent 100 bytes. So probably what happened here is it did the read system call and then it decided to save in a local variable. After our A's had been read in, the code still uses the stack, right, to save stuff. It saved the value 100 right here. So that's why these aren't 4 A's right here. That got overwrote. And so we went right through the saved instruction pointer, and now we segmentation fault, right? Because this turned into a bunch of A's. So normally, as we were doing in previous levels, we would set this either partially or completely or whatever to some win function. We don't get to do that, but these things that are A's right here, this doesn't have to be this way, right? It doesn't have to be a 41. And this doesn't have to be, so again, let me back up real quick. This thing right here, instead of pointing at a code page, could point at the stack, because this page of memory is marked executable, which is not standard. It's, yeah, I mean, it's standard under some circumstances, but broadly speaking, it's not standard. But it is in this challenge. So what we could do, let me make sure there's no follow-up questions regarding this. Yeah, sorry, I'm having trouble. Okay, yeah, there is follow-up. Good, I checked. I'm having trouble finding the shellcode address. I think I currently have a brute force solution for both the padding size and the addresses, but I don't think I'm even remotely close with the address. I usually just brute force the padding for all the .1 flags, but the main, okay, so that's certainly a way to do it. You know, it's a little, you might be losing a little bit of education there, but you know what, a flag is a flag, so I'm not gonna hate on it. I usually just brute force the padding for all the .1 flags, but the main problem this time is finding the shellcode address. I think GDB is messing with it. Okay, so this is absolutely true. This is definitely true, which sounds crazy. Why would GDB mess with your address? But it does. So let's take a look at how it does. So you'll see, for example, that under a normal run, and I recognize that this is the .0 version, you've maybe even solved the .0 version or have an idea of how to do it, whatever. And the .1 is a little different than the .0 procedurally. But you'll see here that the saved return address is here, right? We're even going to copy this down. And this is always going to be where it is. Okay, so we put that there. And we'll say echo NE 100 N, and we'll just give a few A's. Okay, so it is right here again, 288, FD 288. I guess I didn't need to write it down. It is always here, right? And the input buffer also is always here, right? So I'm sure you've kind of maybe thought this through, right? Instead of pointing here like it currently does, right, at this address, make it point at like something like this, right? If it points to the start of the buffer, my A's, and my A's are now shellcode, and we're executing our shellcode, we're going to be pretty happy. And this never changes, except in GDB, it does change, right? As we know. So this, and we'll even write this down, but I don't think this is going to matter too much for us. Well, I guess it will, but let's do GDB challenge toddler 1. If we start this program and we, let's see here, what do I want to do? Let's just continue. Let's just continue, yeah. And we'll say 100, and we'll send a bunch of A's. Good enough. Okay, the input buffer, you're maybe already noticing, before it was 230, now it is 220. It's off by hex 10. It's off by 16 bytes. Similarly, this guy is off by 16 bytes. Both of these things went down by hex 10. Okay, right? So it is changing, and it is in fact 100% that it is GDB that is doing that. GDB has caused this to change. Now, if you run it in GDB every single time, it'll be the same. It'll be always be this, but it's always gonna be 10 different than like really running it, right? Which is super annoying because you need to make it work outside of GDB, but you're using GDB to figure out how to do this stuff. Like, what the heck? Okay, here's what's happening. Info proc environ info environ. Oh, I have to start it again, I think. Oh, well, hold on. GDB start. Okay. Info proc environ. Me. How do I, is there not a good way to do this? There might not be a good way to do this. There's definitely a way to do this. let me think here. Okay, here's what we'll do. Let's just print the stack. So the stack is, let's just pretend that it is at 2000, and we just want to print all of it, like a lot of it. 100 GX here. Okay, so we're printing a bunch of the stack. And maybe I want to print more of the stack. Trying to make a point here. How do I find this? Printing a lot of the stack. Okay, this is the part that matters. Okay, you might have noticed, right? We had a bunch of addressy looking things. I mean, mostly null bytes, but then all these like 7FFs all over the place, right? And then suddenly we kept hitting enter to go further and further on the stack. And eventually we got something that doesn't look very addressy. Hopefully you're thinking to yourself, this doesn't look addressy, this looks ASCII-y. Basically, if you're seeing like a lot of hex values that are starting with like 6s and 7s, and we see like a 2F in here, this is all of the environment variables. So if I take this thing right here, and I do x/100s right here, I mean, I'm partway through the environment variables. Maybe I could do a better job. Start right here at E8 or whatever. We'll even just start here. Okay, what this is so this is actually argv0, I think. But then this is environment variable, environment variable, environment variable, all of these environment variables. Okay. And you might think that I am lying to you, but I am not lying to you. That, where is it? This guy right here, columns. I thought there was another one. Lines. These two guys right here. I have no idea why GDB does this, but GDB adds these two environment variables in. It just does. Let's see here. And then there would be like a null byte in there or something, and or maybe 16 bytes. Is that just two pointers? I don't know. This is what it is though. If we go out of GDB, info, or we just type env, you'll see we have a whole bunch of environment variables, but none of them are called columns or lines. And everything else I'm just going to tell you right now was already in GDB. And GDB also has columns and lines, which sounds insane. It sounds absolutely insane, but it is true. And that is why it's different by 16. This right here. Okay, how do we deal with that? Well, look at this. So this was GDB and GDB, and this was our original and our original. Let's even just run it again with our echo, right? We've got 230, 288, whereas GDB reports 20 and 278. Here's what we're going to do. We're just going to add columns and lines. I think I have to say export. And export. Okay, so now these are part of my environment. I grep for columns. And I grep for lines. These are now sitting in my environment, which means when I exec VE to start this program, these will be passed as environment variables into this program. And it will now line up with GDB. 210. Uh-oh, not true. What do you mean no? Something else might have changed. How did I do GDB? What the heck also changed? Now I'm confused. It's definitely going to be something similar to this. 100, some A's. That's still 220. X/S. Wait, where the heck was it? Wait, what? Oh, I'm going the wrong way. Wait, what? X/S RSP 1000S. Oh, did it start? Continue 100. Oh, but it didn't break. I see. Just kidding. Start. X/1000S RSP. Okay. Trying to think what else it might be adding or removing. I've got a feeling it's this underscore equals user bin GDB. Let's see. N grep underscore. Oh, yeah, it's probably this. Well, okay, here's what we're gonna do. We're going to does reset clear the environment? I don't think it does. Grep column. That's still there. Unset columns. And grep column. Okay, so we got rid of columns. Now if I run the challenge here, and I start, and I continue, and I say 100, and I say A's, we just need it to line up with GDB. So 220 and 278, 220, 278. Echo 220, 278. All right, so we just got to mess with our environment. We ended up, truly, we could do a deep dive on this. I don't know if we're going to do that right now. I'm not sure what else is affecting the padding. It didn't really matter that we added these specific things. We just had to make it so that the amount of space being allocated to the environment that GDB does versus our program does is the same. In doing this, by adding a little bit of stuff, so it looks like it was just a single export. If we would have just done export lines equals 30, that would have added like enough stuff into my environment so that now GDB has the same addresses as outside of GDB has. And now it's way more debuggable. Hopefully that answers your question. That should mean now you can use GDB to discover this. So for example, right, it's saying the buffer start is here, which means all I need to do is get this address right here. Okay, get this address right here, get my shellcode into here, assuming this is enough space for my shellcode. If it's not, well, we got other options potentially, and that would be that. Another option, if this is not enough space, I guess I'll say, so you can put your shellcode down here, right? And of course the stack continues. So you could have address to the stack that's right here, and your shellcode just begins right here, right? If this right here is not enough space for you, put your shellcode down here, return to right here. Okay, any final questions before I wrap up this office hours? I see, is there a Y grade in this course? No, I don't think that's an option for me. I know that Y grades were definitely a thing in like 2020, maybe even 2021. I don't think I can give out Y grades anymore. For 2.1, is it the same address as 2.0? If you're lucky, it is, maybe, possibly. That would be pretty lucky. Hopefully not, though. But it's randomized, I guess I'll say. Can't we get I grade and then retake the class? Can't we get I grade and then... I don't know the procedure. I think at some point your I grade has to be filled in with something. I don't know how this stuff works in terms of, like, so for example, if you're talking about the academic integrity stuff, if, for example, we give you an I as we process the case, and then AIO, Academic Integrity Office, says assign zeros for these modules, and that brings your grade down to, let's say, an E. I believe that I grade would be filled in with an E. And then in a separate semester, you will have taken the course again, and you will have gotten, let's say, an A or a B or a C or whatever the heck you got that's, you know, a passing grade. If we assume that that's the path of what happens. I don't know how that affects GPA, for example. If that's what if your goal is to, like, help your GPA the best possible way. My understanding is that I grade has to be filled in eventually. And I don't know how, if GPA just goes off of the highest grade or if it does the average grade. I really don't know. I'm going to say that this is going to be a question for either advising or academic integrity or whatever. I'm going to have to tell you that, yeah, if you find out, maybe the rest of the class would love to hear. And you could feel free to share that. But I'm not going to be looking into that. That's an ASU question. Thanks for answering my question. Also, isn't there a belting ceremony for those without an AIV? Any idea when that'll be and where we'll hear about it? Yeah, very good question. I was discussing this with Jan actually just before this office hours. We're currently planning it. I think there's some idea it might happen tomorrow, and some idea that it might happen tomorrow. I don't want to, I'm not committing to anything. We're going to announce it as soon as we have the details. It might happen tomorrow. It might happen tomorrow during when the final for this course normally would be, so that hopefully as many people that are free to be a part of the belting ceremony that don't have an AIV pending. I guess I'll clarify, if you have a pending AIV, you are also ineligible, right? Not just closed cases. There is no final exam, but there is technically a 2 hours scheduled for this course to have a final exam if it chose to have a final exam. But we do not have a final exam, but we might use that 2 hour window because we know you're all free and not in a different final during that 2 hour window. I'm telling Jan we should probably use that for the belting ceremony, but I have to confirm that that works. So an I grade changes into an E after a year, just looked up. Yeah, exactly. So at some point that I does not just forever stay an I. That would be, yeah. So if we retake the class before the end of the year, will we be entitled to the new grade? I'm going to guess that if you're getting an E as a result of like academic integrity stuff, probably we're not going to be playing weird games with the ASU system to help boost your GPA. I don't know whether an E gets replaced in your GPA or averaged into your GPA. I really don't know how that works. But I'm going to say that that is at the discretion of the Academic Integrity Office for however that works itself out. Whatever the standard way is that the Academic Integrity Office processes that, yeah. Is this an online event or on campus? Yeah, so the belting ceremony will be on campus. We'll make an announcement of this and also stream to Twitch. So if you want to collect your belt in person and you do not have a pending academic integrity violation, you can do it at that event that we announce. Alternatively, if for some reason you can't make it or it's not convenient for you or whatever, we can figure out how to tell you like when we're available to give you a belt. Just like it wouldn't be on stream and it wouldn't be a part of a ceremony, but of course, you know, if you earn your belt, you earn your belt and you can still get your belt. So the reason it's an I grade, my understanding, is because your grade hasn't been fully figured out yet, right? Like I can't just go forward and give zeros to everyone that I suspect just off the bat. That would probably be considered unfair to just immediately assign those zeros, at which point I would know what your grade is and give you an E or whatever. Technically, we could do that, probably not, but we could imagine doing that. And then if your case was dismissed for like whatever, fix your grade to some other letter. But it's just an incomplete because we don't know what the heck your grade is until the academic integrity situation resolves, in whether that's the consequences are handed out or they're not handed out. No, we're just going to follow what the academic integrity office says for standard policy, which is at the assignment level. The assignment becomes a 0 for first-time offenders. And for those wondering if this is going to be your first time, I think I put it in the notice, but if you have multiple assignments, each assignment will become a 0, but this is still considered one instance. I think there's some terminology that the academic has. They call it like a simultaneous incident or something to that effect. So it's not like if you are being accused of 3 assignments that it's suddenly going to be considered 3 instances of academic and like you just like immediately to XE and like, you know, that sort of thing. No, it'll just be considered one offense in the eyes of the academic integrity, but grading it will be 0. So when will the grades be posted? So grades will be posted on Monday. I'm normally, you know, kind of bad about grades, as in probably Monday after, like late afternoon / Monday night, but hopefully Monday before 5 p.m. but definitely Monday before midnight. I will definitely say it'll be Monday before midnight. However, if you have a pending academic integrity, whatever, what's going to go in is an incomplete. I think we'll have enough time with the academic integrity office where if people want to just close out their case, right? I don't think you're going to get a whole lot of value out of trying to dispute this with academic integrity. You're entitled to do that. I don't think you're going to find a lot of value there. You will be able to respond to some sort of email that academic integrity will be sending to you later this week, and you'll just say, yes, I confirm that I did this. Please close out my case. You do that. The academic integrity will email me and say, please assign zeros for these assignments for this student. I'll enter that in. Your grade will close out on Monday with everyone else. I'm not sure if I'm allowed to ask. Yeah, so I discussed this a little bit in the notice. I'm currently thinking about a 60% for a C. Normally it would have been a 70%. I'm thinking a little bit about a 60. Some other grades would adjust. I'm not adjusting an A+. I'm thinking, but for those wondering, like on the pass-fail level, right, where a C is a pass, I'm thinking about bringing that from a 70 to a 60. But I'm not confirming this. I will confirm this on the Discord. Yeah. So academic integrity office determines the consequences of all of these violations. I am telling them that I have this evidence and I feel very strongly about this evidence. So evidence and accusation is absolutely coming from me. It's not coming from academic integrity. But the consequences for those violations are being determined by academic integrity. I'm just doing whatever they say to do, which for first offenders, after discussing with them, is going to be zeros on those modules. I'm just pre-warning you that this is what the consequences are that academic integrity are going to tell me. I've already pre-reached out to them to understand the situation, but that has been determined by them. If something weird happens and academic integrity says, you know what, do this instead, I'll listen to them. But I would suspect that won't happen. Yeah, an A-. So if I do have a curve, if we do, as this course, have a curve, A- I will adjust. So let's see here. Am I thinking about this right? So these are the current thresholds. So again, I'm not confirming this, but something that I'm thinking about, whatever, we'll just let it put its, something that I'm thinking about is something like this, I think. Again, this is not a assertion of this curve, but I am thinking about doing something like this. And then also there is I guess we don't have that here. I think normally, I don't know, we could search the ASU cutoff. I don't know, maybe I would do like, I don't know what it normally is. Maybe 55 or maybe even 50. I don't know. Someone was pointing out to me that there is some value to a D versus an E, which I wasn't aware of. I don't know. I might make it something like this. It might be like 55. I'm really not totally sure. Probably you should. Don't count on anything, okay? But this is what's currently in my head, and I will announce to the class when I decide. The A plus is definitely not changing though, and a discussion on that one. But this is what kind of is floating towards the top of my mind, just so that you're aware. But if you're really counting on this sort of thing, right, like I encourage you to do more challenges, right? I'm not committing to this yet. I will try to commit to this as soon as I possibly can. People failing 4 modules subtracts 44% straight up. That's failing for sure with the curve. Yeah, I guess if you go from 100 and you ended up at a 54, that would probably, yeah. I guess a little bit of extra credit might do something there to make a difference. But I guess no, I think we only offer up to 5% extra credit. Yeah, I mean the curve is to help everyone as much as I think is reasonably fair to do so. I will say though, in as non-offensive of a way as I possibly can, if you have been accused and confirmed of cheating on 4 assignments, I don't know that it necessarily makes sense for you to pass the course. I don't mean that to be mean, but that's just kind of a statement of fact, or not fact, a statement of my opinion on that. But not trying to be mean about that. It's just the curve will be what the curve is. I'm a visiting student, but would like to do challenges in this point, even if yeah, the challenges will still be fully available. If I'm below 100%, like 99.5%, but have some thanks and meme extra credit, will I still? Yes, yeah. So this is just off the percent. So obviously maybe the simplest way to get an A plus is to complete everything on time. But obviously that's, it is a tall ask. Maybe we could imagine an A plus policy that requires that, but we're a little more generous. You can use extra credit to get you the rest of the way there. Yeah. And in fact, if you're currently at a 99.5, and you have, I don't know, if you have 2 good memes or whatever, or like a decent amount of things, I don't know, it's like log base 100. So that means like 10 thanks is worth 2.5%, or, I don't know, you do the math. But yes, that would still make you eligible for an A plus. I will say though, just as a forewarning, don't do weird things with the helpfulness extra credit. If we discover that people are like trading thanks or illegitimately offering thanks to people, that will be an issue that I would not recommend people find themselves in. But obviously people are probably still looking for help during this week, so you know what, offer some help. Make sure they offer you thanks so you get your extra credit, get your A plus, etc. When will our grades be updated in pwn after the AIV deduction, or does it only happen when we reply our confirmation to ASU? So yeah, if you go through with kind of the simple academic integrity path, which is academic integrity emails you on Wednesday, Thursday, or Friday, really not sure when, and you just immediately reply back saying, yes, I confirm I did this. I would like to close out my case. Probably this won't actually, I don't know, given the timeline, if this will really update in pwn.college. It'll probably just update in like you see a grade posted on my ASU, which is your final letter grade. people cheating on one module and people cheating on 4 modules having access to the same PDF treated differently. Yes. If you cheated on multiple assignments, you will be treated differently from people that did not cheat on multiple assignments. I mean, everyone's going to get an academic integrity violation. But in terms of if we have evidence of you cheating on 1 assignment versus 4 assignments, I think it makes sense. You know, you get a 0 on 1 assignment versus 4 assignments. I think that's probably pretty reasonable, and that is likely what academic integrity will inform us to do. If we wanted to continue taking classes like CSE365, would you, 466, yes, I would encourage you to take CSE 466 if you really like this type of material. It'll dive more into the binary exploitation. So if you like 365 but you didn't like the binary part of it, maybe you're not going to be thrilled about it. But I think there's some really cool things to learn in 466, and I would highly encourage you, if you liked it, to take that course. I will also point out that CSE 466 is only offered in fall semesters, so keep that in mind. So you would be able to take it next fall, but you would not, for example, be able to take it next spring. So if you're thinking about when you might want to take that, just factor that in. It's only available in the fall, or at least that's how it's always been. I don't know, it could change, but I don't think it will. How is the academic integrity violation detected? Just curious. The current method was just going through a bunch of files / deleted files, very in an automated fashion, detecting identical files to people, and then also manually confirming that identical file. Basically, I looked for files in which at least 5 people had exactly the same file of, and then I manually analyzed that file to determine if it came from some sort of cheating PDF / if it looked reasonable that multiple people might have written that same code identically or not, etc. So I manually reviewed all of the instances that I'm feeling highly confident about. But it was kind of a straightforward thing. So anyone thinking about, I will say though, anyone thinking about, next semester I just know what to avoid now, don't do that. Please don't do that. I already know how to make this way more sophisticated. This is just like the boring, really easy to catch stuff. But both have literally the same unauthorized content, and both won't be affected the same in real time. Both won't be affected the same in real time. Not sure what that means. When will the academic integrity webpage be updated? I remember you saying you would run the script again. It likely won't be updated, but I will reach out to individuals with updated academic integrity notices at that point. So yeah, I mean, realistically, it's currently analyzing, so don't think you're gonna like delete stuff to get away with it. I'll probably, realistically, I'll probably just notify people on Monday, as in a week from today when grades are due. So just don't cheat. Please don't cheat. But I will notify those individuals on Monday likely, because that'll be it'll just be one final, collection. Yeah. So if anyone's thinking I'm not going to be looking for cheating this week, you would be making a big mistake. Don't do that. That would be a bad idea. Yeah, the sun's lost. Very sad. Yeah, I know there's paranoia. I will say though, I'm very, very, very confident in my accusations. I think maybe I'm being too naive here, but I think everyone that cheated knows they cheated. So I think if you will get caught on Monday. I understand the paranoia, etc., but I've got a very good feeling that everyone knows what they've done. Yeah. But I recognize the paranoia that you're like, is there any chance that he caught me as having the same file as someone else, but I know I didn't, blah, 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 blah. Like, I know I didn't cheat, but I understand. But yeah, that's what I'll say about that. Yep. Okay. Any final questions? It's been a 2-hour class. Hopefully we got a decent amount of content discussed. And obviously I understand people had questions about academic integrity. If people continue to have questions about the last module, or I guess any of the modules, of course, reach out on Discord. If you have, procedural questions about academic integrity, please feel free to reach out on Discord about that. I'm happy to answer as much as I can about the process if there's confusion. Hopefully the notice describes most of it. If you have a dispute, if it has something to do with like, I don't think I cheated, or please don't report me, or I don't like this policy of how you're going about this, or something to that effect, you have to do that through the dispute link. But otherwise, yeah. All right. We'll see. I'll try and schedule maybe a meme review to go rapidly through all the memes / a bonus office hours. On the off chance I don't, though, thank you all for attending this class this semester. I know we've had especially some hiccups here at the end. I think I'll schedule another one, but just in case, goodbye and good luck. And I'll see you at the belting ceremony when we announce that. And I'll talk to you on Discord, etc., etc. Goodbye.